Have you ever looked up at the night sky and seen a sudden new point of light? It's not a plane and it's not a satellite. You might be witnessing one of the most spectacular events in the entire universe, the death of a star. But this isn't a quiet fading away. It's a glorious, universe-altering explosion known as a supernova. Imagine a star far more massive than our own sun, reaching the end of its long life. For millions, even billions of years, it has burned brightly. But now its fuel is spent. In a final defiant act, it collapses and then explodes in a cataclysmic blast. In that single breathtaking moment, it shines with the light of billions of suns. This cosmic firework is so incredibly powerful that it can outshine its entire home galaxy, a galaxy that might contain hundreds of billions of other stars. And this isn't just a fleeting flash. It can maintain this stunning brilliance for weeks, a temporary beacon visible across unimaginable distances. But why should we, here on our tiny blue planet, care about a star exploding millions of light years away? The answer is profound, and it's closer than you think. It's in your bones, in your blood, in the very air you breathe. Because you, me, and every living thing on Earth are made from the remnants of these ancient, violent explosions. We are, quite literally, the children of supernovas. To understand this, we need to journey into the heart of a star. Every star is a colossal nuclear furnace. Deep within its core, immense pressure and temperature force lighter elements to fuse together, creating heavier ones. The process starts with the most basic element, hydrogen, which fuses to become helium. This is the same process that powers our sun, releasing a steady stream of energy that has sustained life on Earth for eons. As the star ages, it continues this process, fusing helium into carbon, carbon into oxygen, and so on, building up a layered, onion-like structure of progressively heavier elements for most of its life. This nuclear fusion creates an outward pressure that perfectly balances the star's own immense gravity, which is constantly trying to crush it. The star exists in a delicate equilibrium. But this cosmic alchemy has its limits. Eventually, for the most massive stars, the core begins to produce iron, and iron is a game changer. Fusing iron doesn't release energy, it consumes it. The furnace at the heart of the star sputters and dies. Without the outward push from fusion, gravity wins. And it wins catastrophically. The star's core, which could be larger than our entire planet, collapses under its own colossal weight in a fraction of a second. It implodes at speeds reaching a quarter of the speed of light. This sudden, violent collapse causes the core to heat up to billions of degrees and become incredibly dense. The implosion then rebounds, sending a stupendous shockwave rocketing back out through the star's outer layers, and then boom, a supernova, the shockwave tears the star apart, flinging its contents across the cosmos. It's in this crucible of unimaginable heat and pressure that the universe performs its greatest magic trick. Elements heavier than iron simply can't be made in the normal life of a star. They require the insane energy of a supernova. It's here that the universe forges precious elements like silver, platinum, and gold. It's here that it creates uranium, iodine, and all the other heavy elements that make up our world. Think about it. Without supernovas, the universe would be a far more boring place. After the brilliant light fades and the outer layers of the star are blasted into space, what's left behind at the epicenter of the blast is often just as mind-bending as the explosion itself. In many cases, the collapsed core of the star is compressed so tightly that protons and electrons are squeezed together to form neutrons. This creates a neutron star. A neutron star is one of the densest objects in the known universe, second only to a black hole. Picture this, an object with the mass of 1.5, maybe even 2 of our suns, crushed into a sphere only about 20 kilometers or 12 miles in diameter. That's the size of a small city containing the mass of a star. To give you a sense of this insane density, scientists have a famous comparison. If you could scoop up just a single teaspoon of material from a neutron star, that tiny spoonful would weigh about 1 billion tons. That's the same weight as Mount Everest, or 900 Great Pyramids of Giza, all crushed into the palm of your hand. You can't even begin to wrap your mind around that. These cosmic monsters also spin incredibly fast, sometimes hundreds of times per second. As they spin, they can shoot out powerful beams of radiation from their magnetic poles. If one of these beams happens to sweep across Earth, we see it as a regular pulse of energy, like a cosmic lighthouse. We call these objects pulsars. So, you might think of a supernova as an act of pure destruction, the violent end of a magnificent star. But in the grand scheme of the cosmos, it's not an end at all. It's a beginning. It is the ultimate act of cosmic recycling. The explosion scatters all those newly forged elements, the life-giving ingredients across vast stretches of space. The iron, the oxygen, the carbon, the gold. They all become part of enormous clouds of gas and dust called nebulae. Over millions of years, gravity begins to pull these cosmic clouds together. Clumps form, they grow larger, they spin, and they heat up. Eventually, at the center of a new, swirling disk of matter, a new star ignites. And around that new star, the leftover dust and debris, the ashes of the supernova, begin to stick together, forming planets, moons, and asteroids. This is exactly how our own solar system was born. Our sun is not a first-generation star. It formed from a nebula that was enriched by the remains of one or more ancient supernovas that exploded billions of years ago. The very ground beneath your feet, the rocks and metals that make up the earth, were forged in the heart of a dying star. If a supernova is the death of a star, it is also the mother of countless new worlds and the potential for new life. We aren't just detached observers looking at the universe from the outside. We are an intimate part of its grand cyclical story, molded and shaped by its most powerful and catastrophic events. So, the next time you look at a gold ring on your finger, take a moment. The atoms in that ring were not made on Earth. They were created in the final, fiery moments of a massive star's death, an explosion that happened long before our planet even existed. Every time you feel the iron-rich blood pumping through your veins, remember that iron was the element that sealed a star's fate, triggering the supernova that would eventually seed the cosmos with the building blocks of you. This is a lesson that is both humbling and empowering. We are made of stardust. We are composed of the finest, most precious materials in the universe, elements forged in the most extreme conditions imaginable. In a very real sense, we are the universe experiencing itself. We are the way the cosmos perceives its own beauty and ponders its own mysteries. So cherish your life, cherish the world around you. A star billions of light years away and billions of years ago had to live its life and then sacrifice itself in the most magnificent light show in cosmic history. Thank you for exploring the incredible story of supernovas with us today. The universe is full of wonders just waiting to be discovered. If you enjoyed this journey, don't forget to subscribe and hit that notification bell so you can join us as we continue to decode the mysteries of the cosmos. Thanks for watching.